Hi guys, I want to go over your final review assignment to make sure that you are all very well prepared for your final exam tomorrow. Remember, your final is worth 10% of your overall grade, so you want to make sure that you know how to do all of this stuff. Let's look at our first part. So for this, we want to find how many solutions each system of equations has. So if we have a graph, and when we graph it, we have two lines and they intersect at the point 4, 5. Since that's the only point that they intersect, we're going to say that this has one solution, and that solution would be 4, 5. For the next problem, a system is graphed that has two lines that are parallel. Well, we know that parallel lines never intersect, and since they don't intersect, that system would have no solution. Finally, a system is graphed that consists of two identical lines. Well, if we have two identical lines, we have the same line graphed on top of itself, which means every point on the line is a solution. And since every line has infinite points, there are going to be infinite solutions to this system. For this slide, you had to figure out which method would be best to use to solve each system. So if I look at my first system, I'm going to always start by looking at my coefficients. So my coefficients of x and my coefficients of y. My coefficient of x in my first equation here is positive 4, and in the second equation is negative 4. Well, I notice that those are opposites. Since those are opposites, I could add both of these equations together, and I could get rid of my x's and then just solve for y, which means this would best be solved by elimination. Next, I have x plus 2y equals 16 and 3y minus 5 equals 4. Well, if I look at my coefficients, I notice that x has a coefficient of 1 and this y has a coefficient of 2. In my second equation, I don't have an x, but my y has a coefficient of 3. Well, none of those can be easily eliminated, so instead I'm going to look at either substitution or graphing. Well, if I look back at my first equation, I notice that x has a coefficient of 1. And if x has a coefficient of 1, then I can easily get it by itself on this side of the equation by subtracting 2y from both sides. So once I have x by itself, I would substitute the other part of my equation into my second equation. Because I can get x by itself easily, substitution is going to be my best method for solving this system. Finally, we have y equals negative 2/3 x plus 4 and y equals x. Both of these equations have y by itself, so they both have y with a coefficient of 1. And if I notice in my first equation, it looks as if I'm given a slope, negative 2/3. So I would have a negative 2 as a rise and 3 as a run. Because of that, this one would probably best be solved by graphing. Now we're going to look at some variables that would give us correlation. So the first one says the number of bedrooms in a house and the cost of electricity. I always start out when I want to know what type of correlation something has. I start by asking about the first thing. So the first thing here is the number of bedrooms in a house. And I would say, as the number of bedrooms in a house increase, what happens to the cost of electricity? Well, typically, the more bedrooms you have in a house, the bigger your house is. And the larger your house is, the more it costs to provide it with electricity. So as the number of houses or bedrooms increase, the cost of electricity typically also increases. And because both are increasing, this has positive correlation. Next, the number of flu cases and the number of people at school. So again, I start by saying, as the number of flu cases increase, what happens to the number of people at school? Well, the more people who have flu, so as that goes up, I know that typically the number of people who are at school goes down because those people are staying home because they're sick. So as the flu cases increase, the number of people at school decreases. And if one of them is increasing while the other is decreasing, this has negative correlation. Finally, a person's shoe size and the size of their house. If I say, as a person's shoe size increases, what happens to the size of their house? Well, typically, one shoe size has nothing to do with the size of their house. So I would say that this has no correlation. Now let's look at this scatter plot, and we need to find the equation of the line of best fit. So again, when we're finding the equation of a line of best fit, equations of lines always need to be written in the form y equals mx plus b. So we need to find, first off, our b, or our y-intercept. In this case, when I look at this line intersects the graph right here at 0, which means my y-intercept is going to be 0. Now, since I know my y-intercept, I now need to find my slope. Remember, when we're finding slope, that's always going to be rise over run. So I'm going to start at my y-intercept. Now, I'm going to go up on my graph until I find a point on the line that I can use. None of these are points that I know their exact value, but when I get right here, this point on the line has an x value of 15 and a y value of 100. Some of you are getting confused here because you think you need to use a point from the scatter plot. It does not need to be a point from the scatter plot. What it needs to be is a point on the line. So you'll notice I'm making this point right here, and this point is not a part of the actual scatter plot, because what I need to find is a point on the line. Now, to get from this point to this point, I would rise, and yes, I would go up 4 units, but my rise is not 4. My rise, if you notice, every unit here is going up by 25. So my rise is up 100. And then I would run right, and yes, it would be 3 units, but when you look at my units on my x-axis, each one of these is 5. So now I'm running to the right 15 units, sorry. So that means that my rise here is 100 and my run is 15. So when I write this equation, it would be 100 over 15 times x and then plus 0. Now what I do want to do is simplify my fraction. I don't want to change it to a mixed number. I want to leave it as an improper fraction. But 115 can both be simplified by dividing both of them by 5. So if I do 100 divided by 5, I would get 20. And if I do 15 divided by 5, I would get 3. So this would become 20/3 x. And then I have this plus 0 here. And technically, I can write it if I want, but I don't need that because if I add 0 to 20/3 x, it's still going to be 20/3 x. So when I type my equation for my line of best fit, I would write y equals 20/3 x. Now I need to use this equation to estimate the burning time of a candle that weighs 50 ounces. So if I notice, my candle weight is my x-axis. So this is telling me that I have a weight of 50 ounces, or I have an x value of 50. So I'm going to take that and plug it into the equation I found. And that equation was y equals 20/3 x. So I'm going to multiply 20/3 times 50, or 50 over 1. And when I do that, I get 1,000 over 3. And that, if you would divide it, becomes 333.3 repeating, or 333 1/3. So if I were looking at the burning time for this candle, I would say that it would be about 330. At our two-way table. So for this two-way table, I'm always going to look at what I have mostly filled out. So if I start with my left-handed column, I know there were 17 boys and 29 total people who were surveyed. So to figure out how many girls I had, I would do 29 minus 17. And 29 minus 17 gives me 12. Now, if I go to my right-handed column, it doesn't look like I have enough information to fill either of these out yet. So I'll go to my total column. In my total column, it looks like I have 35 boys and 70 total people. So to figure out how many girls were surveyed, I would do 70 minus 35, and that also gives me 35. Now, to figure out what's here, I still can't use the column, but I could use the rows. So for boys, I know that I had 35 total boys and 17 of them were left-handed. So to figure out how many were girls, I would do 35 minus 17, which would give me 18. Now I can use this 18 to find the total number of students who are right-handed by adding 18 right-handed boys to 23 right-handed girls, which would give me a total of 41 right-handed students. Now I just use my table to answer my questions. How many girls were surveyed? Well, if I look at my girls row and go over to the total, there were a total of 35 girls surveyed. How many people are right-handed? If I look at my right-handed column and go down to the total, there were 41 total people who were right-handed. All right, this is it for your final exam review. Please make sure that you understand how to do all of this. And if you have any questions, email your teacher before it's time for you to start taking your final exam. Good luck tomorrow.